Inventory systems are widely used in a game development. Sometimes you just want to show a list of items, but sometimes you want to also drag them between slots, swap, or drop outside. In this episode, we will focus on the UI side of that problem. We will implement a reusable drag-and-drop UI component in Godot 4 using C#. This component will serve as a foundation for an inventory system. In the next episode, we will create data model and wield UI and the model into a fully functional extensible system. Let's get started. Open a new Godot project, create root UI node, and save scene as a main. Create two folders, JFX for icons and other graphics, and SRC for scripts. Inside JFX additional create UI directory. We will place our assets there. Download assets archives using the links in the description, or you can find them in the tutorial repository. Extract the archives in JFX UI directory or anywhere you wish. Now let's create necessary UI elements. I've illustrated the entire node structure we need in a diagram. So, create a panel container and place a 9-patch rect and a margin container inside it. Inside the margin container, nest a grid container, then a panel container, then a button. Rename panel container into a slot and grid container into a slot grid. Save slot and its children as a scene. Let's also create a separate directory for scenes, call it scenes, so nothing is scattered around, and name the scene slot scene. Do the same with slot grid and slot grid scene. Now let's configure the created elements. Open slot grid scene, duplicate the slot several times using Ctrl-D, and you'll see they are lined up in a single column. Let's set columns value to 5 in the inspector. Now open slot scene and configure the panel container style. Create new style box flat at inspector. Assign any icon to the button. In the slot style box, add 3 pixel border on all sides and choose a color you like. For example, this one. I'll leave the exact color code in the description. Also configure the background color. Add corner radius of 5 pixels on all sides and enable blend for a smooth transition between the border and background. And finally, set mouse filter to propagate up for button and a panel. So mouse events captured by the button and a panel were able to propagate up to the grid. Sure, what for else? Now we have, in my opinion, a pretty aesthetic button. Go to the main scene and configure the 9-patch rect so our grid has a background. In the inspector, set texture to one of the previously added box sprites. Click Edit region to open the sprite border editor. Move the stripe lines on all sides so the frame of the sprite remains outside. This tells Godot which parts of the sprite should be deformed when resizing. In the margin container, set margins equals to 8 on all sides so the background frames becomes visible. And now we are done with setup UI nodes. Now let's move on to describing the UI logic. In a menu, go to the project, Tools, C#, create C# solution. Next, go to the slot scene. Assign unique name to button node. And assign a new script to the root. Name it slot UI node and save it to SRC UI directory. Open the new script, create a private constant with name of our button, unique name, and in ready put its reference to the field. Enable nullable syntax in the project. We'll use it later. Suppress warnings for the previously created button variable, since we assign it in ready and no chance it can be null. Actually, it can be, but in that case, if we use getNode method, it will show us big red error message in the console, so we notice it for sure. Let's look at the slot scene. On the right, you can see the events that the slot needs to report when they occur. We will need to create them. Let's create all these events in a single one that contains information about what exactly happened. Inside Ready, subscribe to GUI input and mouse entered and exited events of the button. Edit the arguments data object class we created earlier. Create an enum type with 4 values. Click, release, entered and exited. Inside arguments, create a field for the type and an enable mouse button field. Create a method invoke slot mouse event that takes the event type and the mouse button index. Then call this method in mouse entered and exited, passing the corresponding enum values. Now we need to determine when the user pressed the button and when they release it. We'll check that inside the method subscribed to GUI input. Check the event type. If it's not input event mouse, return. Then, in the MB variable, we'll have the mouse event. Check the pressed flag. If true, invoke the event with type click. If false, release. In both cases, pass the mouse button index in the second argument. And to remove the warning, make the event type nullable with a question mark. That's it for the slot. Now let's move to the grid script. Open slot grid scene and add a script called slot grid UI node. Let's look at our diagram again. We need to create two events, swap and drop out. The first reports that the user dragged one slot onto another. The second reports that slot was dragged outside the current grid. In swap args, we will pass from which slot and to which the drag occurred. Make both properties required. In drop-out arguments, add a field to store the slot that was dropped. In ready get all children of type slot UI node, create a dictionary to store slot IDs and their references. Loop through all found children, add them to the dictionary and subscribe to their event. Create a helper method to get a slot ID. Here I realized I forgot to set the sender type and the delegate to slot UI node. Let's do that. Print event info in the event handler to make sure everything works. Run the project, set main as a default scene, and verify via logs that result is fine. Great. When pressing slots, pressed is triggered. On release, released. When the cursor enters the button area, entered is triggered. When it leaves, exited. Now let's implement adding slots to our grid. Create an add slot method. Of camera I created a slot data class, so if in the future we need to pass more data to create a slot, it was easy. Create a property with the expert attribute, where in the editor we'll specify which scene to use as a slot. Add a no check and throw an error if it fails. Instantiate the scene into a node, add it as a child, and set the icon. Add created slot into the dictionary, store its ID in a variable and return it. Create a method to remove a slot by ID. If not found in the dictionary, return false. If found, call free and remove it from the dictionary, returning true. Go back to the editor, rebuild the scene so the exported field appears. In the inspector, assign slot scene. Hide the pre-created slots and create a script for the root node in the main scene. From there, we'll control the entire inventory, assign a unique name to the grid node and get it in ready. Create a new folder for the item resource and create the resource class itself. It must be partial, inherit from resource, and have the global class attribute. Inside, export a texture property. In the root node script, create an array property of these resources named items. In ready, iterate over this array and add a slot for each item. Take the texture from the resource, add a null check and move this into a separate method called addTestItems. Now rebuild the project and reload it from the project menu tab, otherwise the new resource won't appear. After reloading field items with 3 resources, I choose key, wire and transistor. You can choose others, but later we will create keys for items, so if you want to follow along exactly, choose the same. Now when we run the scene, the grid will be filled with the items from items. And I forgot to subscribe to mouse event in add slot. Subscribe and verify that it works. Let's look at the next diagram. It shows the drag and drop logic. Our task now is to recreate it inside the mouse event subscription. Create 2 slot UI fields inside slot and from drag slot. One control field for drag indicator and one bool is dragging. Now I'll implement the logic according to the diagram. Implement the handle drag and drop method. This is the main method of our component. And in the end, I forget to set this drag into false, which causes a bug. Don't forget it. Subscribe in root UI to swap and drop out events and log them to console to verify everything works. We see that swap works correctly, we swap slots and drop them, but visually it's hard to see. So let's add a drag indicator. Look at the next diagram. Add GUI input handling to the grid. Filter out everything except mouse events, then follow the diagram. Implement a method for the slot to create a drag indicator showing its contents. It's very important to set filter ignore, otherwise the indicator will block mouse events underneath. The created node must be added as a child of the main UI node, so it's always on top and not scaled. Finish implementation by adding indicator movement. Also fix is dragging bug I warned you about. Everything works cleanly now. To conclude this part, I'll show why we couldn't use a non-root node. If the indicator is added as a child of a grid, empty space appears where the indicator virtually is, even though we're holding it. If we add it to the parent, its transform is applied and the proportions get distorted. At this point, we have implemented a reusable drag-and-drop UI component that supports swapping, dropping out, and has ready-to-use event communication. Right now, it's just the presentation layer, and that's intentional. Keeping UI and data separate gives us flexibility and makes the system easier to extend and maintain. If you already had your own inventory system, you can use it. For others, the next episode will implement inventory model itself and connect it to UI component, turning everything into a complete and fully functional inventory system. If you found this tutorial helpful, feel free to leave a comment or share your thoughts, and see you next time.